Welcome to a Montgomery Amateur Radio Club video, Designing a Patch Panel for Better Cable Management, presented by David N3ADE. Our experiences in Field Day 2014 highlighted the need to improve cable management, to resolve issues of wrangling of feed lines and antenna cables, labeling, connector maintenance, adapters, grounding, bandpass, filter insertion, lightning arrestors, quick disconnects, and cable maintenance. This type of cable management could also be very valuable during emergency field operations requiring rapid deployment and flexibility. One of our club members, David N3ADE, kindly volunteered to develop a patch panel prototype and then brought it to our November 19 meeting to demonstrate. This video captures the great discussion of that meeting and is hopefully useful to other clubs addressing the same type of field day or emergency response issues. Also, our very great thanks to David for all his terrific work on this.
Just hold the ends of this thing. Well, I put it on the table here. So we just need to hold the ends here. Oops, sorry. Yeah.
What movie is that from?
Yeah, the thing that ate Pittsburgh. I don't know. The idea I had here is based on a little flicky geometry, perhaps. But the idea was that I would connect everything with. I only need as many patch cables as I have transceivers hooked up. So the idea here is that my patch cable is only going to be about 23 inches. No matter where I need to connect it, I'm off the center here with the rigs, and I'm connecting all the way around the circle here to any antenna. Because your antennas are spread out across the field, you're going to be bringing the cables in on an arc anyway. So I just thought if we had a patch panel that was arc-shaped, and then we arranged it in a radius configuration so that our patch cables are about the same length, then we could integrate the lightning arrestor and or the filter into the patch cable. So that's basically it. If these two gentlemen will stand here a minute, maybe you'd all like to come up and take a quick look at it. You can get an idea. Basically, it's very simple. There are 9 segments. Each segment has a 40-millimeter ball with a 5/8 hole drilled in it and a 4-inch bulkhead connector through that. And these allow literally some amount of wiggle room, that's hard to say,
yeah.
so that you can attach a cable and you don't have issues with trying to bend the cable to fasten. So that gives you some adjustment flexibility.
Where did you get the balls?
I ordered them from China. eBay.
Probably also something you can get like at Michael's or this kind of places too.
Right.
Perhaps.
Another question that came up was strain relief, strain management. So I kind of cobbled this together from junk in the basement. And this provides, depending on how tight it is, a certain amount of strain relief. And you can put a zip tie on here and zip tie it around here once you've connected the antenna in, and then you're getting a better grip on the cable. Terry, I know, spent a lot of time last summer with, was it pine spirits or something, taking tape residue off of the cables. That was a nightmare. So duct tape residue, because we didn't use gaffer's tape in all cases. So that became an issue. I also have a couple of connectors here and some heavy-duty bolts I'll pass around. One is a male-to-male connector, and the other one is a quick disconnect connector for UHF type connections that allows you to hook a patch cable up on the inside. So my thought was that you would fix these connections by screwing them on, and these would be hop-off quick disconnects, so you could come over and move them around with minimal strain and stress to the patch panels and to the patch cables and to the unit. This is kind of flimsy now, but obviously we support it in a more sturdy way. I just wanted to demonstrate the two radius
Loss for the whole field day weekend, holding it up?
No, obviously it would be worse. The idea here is you can make these any length you want. You can stand it on the ground, you can set it as a tripod, or you can put it on a table, however you want to configure it. So there's some flexibility there. And certainly if you get other materials, I just chose PVC because it allowed me to use the wiggle.
Is this a long barrel?
375 at Joel's.
Ah, of course.
Yeah, that's the cheapest you'll find it anywhere, they're like $6, $7 for that one.
Yeah, of course, sure. Anything RF.
That's not an ad, I wasn't paid to make that ad.
He's the man.
So how would the lighting arrestors get integrated in there in the ground system?
My thought was, since you wouldn't necessarily want to purchase a lot of lightning arrestors, that you want to put those on the rig side, outside of the patch panel, to minimize movement and stress. So they would be connected, they'd be connected on this side. So you put your lightning arrestor on, and then you connect your rig in, and then run your cable down on this side of the rig connection.
So you need connection with because the lighting arrestor is also like a sort of a bulkhead connector too.
Right. Yeah, it's like a double bulkhead connector. You could use the male-to-male connector that I'm passing around to connect the lightning arrestor in, because it's just a straight pin through the second set. You're not going to get much dB loss, if any, measurable with that. And then your rig drop comes on the other side of the lightning arrestor. Because those will be fixed, they won't move
A
around.
lot of lighting arrestors like they're on a stud that screws into a plate, right? A ground plate or something. Or ground.
Either way, that could mean that you run into the lightning arrestor, and the lightning arrestors could all be located in one spot, and then from there you patch in, you run into the patch panel with another short cable. So it could be done either way. The suggestion was just maybe put the lightning arrestors between the rig and the patch panel, because that way you only need, a maximum of however many transceivers you're working with.
But don't they need to be grounded?
You want to put the lighting arrestor on the antenna side.
Okay.
Away from the rig. And the other question that follows on is how do you propose or envision the ground cables going to the rigs? It's going to be...
Well, that we have a system for.
Okay.
There's already a system that has worked now, I think.
That was the one that we
days.
had out of field day this past
Right,
year.
that's worked pretty well. So I didn't address that because I didn't see any issues with that.
Well, we had some issues, but they're not related to the design or related to the availability of length, I think.
Right, so yes, you're right. What you're saying is much safer, expensive, because you don't have to have one per antenna on that side. So it's, it's the trade-off. I vote to do it that way though, because I think that's safer. Sir?
And how would you handle grounding the lightning arrestors?
Well, we've already got a method to do that, and we did that at the hash panel last time, from what I understand.
No, we didn't have a real good solution. That's why I said that was another goal of this thing, was to kind of.
All right.
There's this notion too of trying to minimize the number of connectors too. So we're trying to leverage the fact that you have to have a lightning arrestor. It looks like a bulkhead connector, and it has to be grounded. Because we try to get those three things taken care of. And there's one thought was like you mounted a set of lightning arrestors on a copper plate.
You can have lighting arrestors that have male-female connections.
So you
it
can
makes
also
a bulkhead. You put the arrestor on it, the male side going into the bulkhead, and of course the antenna side also being for electric polarities and whatnot. So it's an easty solution.
Okay. Well, then a different design here might be to use the lightning arrestor as your bulkhead capacitor to the antenna.
That becomes a little cumbersome.
It
I
does.
think with your design here, all you have to do is add the lightning arrestor to it, to whatever grounding wires that you have attached to each one of the arrestors. It goes into your bus.
Okay. So maybe an arc plate with your lightning arrestors fastened in to that as
Well,
bulkhead entries or something.
there are a couple
like that?
ways you could do it, but I was trying to keep it simple and practical and yet still achieve the grounding requirement.
Okay. Wait.
Correct me if I'm wrong, but I can't remember a lightning arrestor that's not made expecting to have a bulkhead of some kind, usually the copper or aluminum plate euphemistically called the ground window.
Well, lightning arrestors that have the female connector or male connector on both ends that'll accept the UHF, the SO239 connector on both ends, they don't necessarily have to be in a bulkhead. You could mount them in a bulkhead because one end of the SO239 seems a little longer than the other, so you can probably mount it that way. But
there are inline.
they're inline ones.
And you have to run a ground wire up to it.
Oh,
And it's
okay,
just a little
that's,
screw on the side where you attach the ground.
Right. Now, to me, those seem very flimsy, the gas tube type, but I don't know what the experience of the
Well,
room is.
the
I've never had a problem.
polyplate phaser design, people are pretty much familiar with those, that's what we use in public safety. And you can get them in any type of configuration that you need. The bulkhead process, the William was talking about is, you know, on all those connectors, if you want to do it that way. But we can get into that design work for
Okay.
later presentation.
Okay, I need to let these guys sit down here, so, you had a question?
Yeah, I assume that nothing that I see here is intended to push up against the direct strike.
Oh, no. We're talking vaporized antennas if we get a direct strike. Yeah, unless we had a tower set in concrete with silver soldered connections, I don't think and we're not going to do that for field day necessarily.
There is a documentation that the second which lays out to the electrical industry the proper way to do lighting, grounding, for direct strike,
Okay. I'll leave that to the experts with more experience.
Yeah.
I don't have that much experience with lightning arresting.
When
So I know Bruce and Hank. I was thinking Frank.
One of the main features of the 278 is that it discusses where the lightning will go if you take a path that doesn't want to go. So, for example, you come down a chimney and you go to make a turn and go across the roof. Lightning doesn't make turns.
It doesn't like that.
It goes right diagonally across, and there you've got two holes in your co-op. Okay, I just wanted to bring that.
No, that's a very good point. That's an excellent point.
So this configuration, this definitely does address the strain relief.
Yeah.
And then it's nice to have the same, the jumper is the same length.
You're working with almost the same length. And then, back to what you were saying before about the filters could be inserted in there. Now, for antennas that have, that were just one band, you can put the filters anywhere, to avoid the bandpass. Yeah, you can put the bandpass filter on the outside of the patch panel. But where you want to change your filters around for each rig, you may want to put them on the inside. So they could go in the patch panel. So you can configure your patch panels to incorporate the bandpass filter at the same time. So there's still some details here that I haven't worked out about, supporting those filters and how they would be, connected in. But this is like early stages. We got to choose to work it out and build it if we want to use anything from here. So, questions, comments, anything else? Is that box of stuff? Did it stop somewhere? Sorry. Okay. I just want everybody to look at that. It's probably nothing we haven't seen before. Just wanted to make sure. So that's all I have from a formal standpoint, but I would appreciate if people would, just do some more discussion and bring up some more points here, and we can capture some valuable information. We've already gotten quite a bit of stuff here. We've addressed some of the things that Bruce had brought up originally, which involve flexibility, allows us to connect multiple antennas and multiple rigs, and our controls are at one point. We all agree that labeling is a big bugaboo that we have to solve and fix, and we've got some suggestions on the table for that. Lightning arrestors are a big deal. We need to make sure we address that, how that works. We might have to drag Tom. Who was the person that set up our grounding system? Was it Tom specifically? Okay, yeah, I wish he'd been here. He might have been able to address some of those issues there, because if anybody would know about direct strike, he might have some good experience there. So that's an aspect of what we need to talk about. And then, unfortunately, the worst aspect of this is how much will it cost to build and put together and whatever. Once we figure out what we want to build, I can put together a cost list, whatever. These components aren't very expensive. The pipe was stuff I had laying around in my garage, so I chose to use that. I could have used wood or something else, or the PVC is a better insulator. And the idea to use the balls was just an idea to put a gimbal in there to allow flexibility in the wire. It doesn't have to be that way. This can only run through a metal patch panel, as long as you're prepared to run the cable from the antennas that way. So, a couple of different things. Any other comments, questions? Surely you're not ready for applause. No?
Thank you for doing that.
Okay. This was fun. Coming up with the idea was fun, and drawing the pictures and trying to figure out how I was going to put it together and bring it in. So I'm up last night, with the smelly glue, trying to put the pieces together. I realized when I opened the can that the glue was like gel, and it wasn't going to work. So I got a few of them glued, and the rest of it was like, you have to take like fake. So please take the papers back with you. If you have suggestions or you think of things that we didn't cover here or we talk about, my email is on there, so send them to me, please, and I'll make sure that I consolidate them all and then forward them to Bruce and Alex. That work? Anybody else?
If you get the grounding thing incorporated into this, I think that was part of the challenge we had, because Tom always appears to be the one that knows how to set up the grounding, but if we can incorporate that, his wisdom into the patch panel setup, then it won't be queued up, and then just having it, bringing it out of a box and putting it there.
Oh, yeah, exactly. I expected that we'll revisit this at least one more time with the grounding issue. We can
integrate it into it, so we just.
Exactly, yeah. With the patch panel, or with the patch cable and everything else, that we put an assembly together that shows all of those things. That would be great, labeling, et cetera. Okay. Anybody else have a question specifically for me or a comment for? Yes.
Why do all the cables have to be, I mean, why does it have to be a radial design?
Doesn't have to be.
Okay.
It just makes the
An optimization.
It makes the patch panel, or it makes the patch panel cables, or the patch cables, the same length, so they're virtually interchangeable. That's the only reason. It doesn't have to be.
Does it matter if it's like 2 foot or 2.5 feet, as long as it reaches the furthest one?
No, the whole idea was, and the idea was to keep the patch cable fairly short, and if it's the same length or right around the same length, then it's easy to make up, a set of cables that are interchangeable. You can also make up cables in which you can insert bandpass filters fairly easily. So that was the only criteria for that. The other reason for the 2 radiuses was so that your rigs could come in to one central point and your antennas could come into one central point, and it wouldn't be more than, say, 6 or 7 feet. So to fit on a table or in a fairly controlled location, because we had to tape off the area where the cables came in and keep people from clumping on them. So that's another concern.
Well, that's another idea. So I'm going to put their head on that or get something about, you sort of have an idea of what our facilities look like. It's come up about some ways to kind of manage it. It is kind of awkward because obviously all the cables are coming off the field and they have to come up 30 inches to get on top of the table, and then they have to come back down again and go, they went along the floor and back over the transceivers.
Well, we went over the rafters for some of those.
Some of
Some went under the,
a lot of
other
this was on the
stations over
floor.
the rafters, but others went on the floor. That's right. So there are multiple ways to connect the cables in, but once you're there, your location's fixed. You're not yanking on a cable because your patch panel shouldn't be moving.
The other idea I just want to shut down is if you buy one of those portable plastic tables from Costco, the foldable ones, and then integrate the patch panel into the table.
I got one of those table actually. I got 5.
So the table and the patch panel sort of become one thing, so you don't have to set it up.
Okay. That's a good idea. As long as it fits in my Jeep, right?
Right.
That's not a bad idea, actually. Okay. Everybody hear that?
So you're sacrificing.
And actually, all the cables that would come up in come up this way, and then the patch panel will go on top.
Not necessarily, Dave. A piece of plywood, either bolted to the table or clamped to the table with this fastened on the plywood works just fine. Then you can use the table for the rest of the year for something else.
But see what they, I also say, here the cables, instead of trying to go horizontally, and they spread out, is let them come up from the floor.
You could do that.
And then just on the top.
You could do that.
So,
Well, as you saw, this design can be tilted
Yeah,
any way
same
you
idea,
want.
right.
So, you could have it in any orientation.
We were doing sort of a horizontal patch panel.
Right.
It seems like we should do a vertical one.
You could do that. You could have it vertical, so you can run all your drops over the rafters if you want. You could have it come up from the floor. Yes. So,
Or the cable could be on its side.
Right.
that's true too. You could lay it down.
Well, we had the problem, is the cables were like this, right? They're coming from the antenna.
Yeah, that avoids the number of bends and also keeps it closer to the ground for ease of lighting, arresting connections, etc. Yeah, so that works too. So please, I expect to get some emails. Yeah, I'm not expecting you to send them all tonight, of course, but when you get a chance, when things occur to you, when you're at work and you're bored, you know, or the kids are screaming, or the grandkids are screaming, and you're like, I need 5 minutes alone. You know, go to that place in your head where you think about stuff like this, and send me an email.
Can
Yes.
you specify the problem? You know, exactly what the problem is.
Well, the problem is patch cable management. The problem is antenna drop line management. We kind of beat that to death, I think.
Okay,
in this meeting.
so-
And that's actually on the, that's on here, and it's on the website.
Ah, okay.
So that should, I mean, unless you want me to go into more detail, I thought this was gory enough. So,
I think it helps with.
but if you have questions, or you want to go over any points, sure, send me an email, and I'll be glad to address them. Yes.
We're just going to do our antenna layout. I mean, they try to do it with coax calculations in terms of segments. They identify a segment that goes down the tower, a segment goes from tower base over to some point, and another segment that goes from that point into the transceiver. So we have sort of those segments. So from the top, where the height down to the ground, and from the base of the antenna into the collection point, whatever. So it was helping to calculate, helps to be able to calculate coax lengths and segments. To that model.
Okay. Right, well, if you're, again, this doesn't have to be this design. This could be laid out on a bigger arc, a smaller arc, not an arc, you know, small boat, anything like that, if you want to look at it that way. This is just an idea to start.
Right.
So, anything else? Because it's only 8:30. We got an hour to kill.
Question. So if the presumption is all these barrel connectors are mounted on insulating material?
Well, wood and PVC.
Okay.
They don't have to be, but
As opposed to a large metal sheet?
Again, that goes back to your lighting issue. If you want separate lighting arrestor for each one, that you wouldn't want to mount them in insulated fashion. You want to mount them all on the same piece of metal and do your lighting, you know, grounding once, probably. That's another possibility. Yes?
And one of the items that I saw on the system was these lightning rods, the gas type lightning rods.
The gas, yeah, gas
And they
issue.
put it into normal place where the antenna came into the building, the cable came into the building.
Right.
And then at every receiver, radio receiver, they'd have a duplicate lightning arrestor.
Right.
And the idea was that between the two lightning arrestors, you could get, you could break down any high voltage that was generated by the alternate resonance of the first one. And the second would take care of it.
Everybody hear that?
No.
Okay, you have two lighting arrestors, one at the antenna and one where it comes into the building or your structure, the other one at your rig.
That's right.
And they're both the same type. Then hopefully you will control the lightning path and you'll get enough resonance from the first arrestor so that it won't get in and zap your rig. Is that close enough?
Yeah, I wasn't too clear. The main idea is two arrestors each for each antenna.
Okay.
I assume you want to have the patch panel inside the building?
Well, it's a field day structure. The whole idea here, you know, aside from what
It
you
was a
do in the
pavilion
building,
last year. Pavilion, so the
was-
side
what
was
do we-
open, just a roof.
So a premise of lightning protection is you don't bring the lightning into your building and then try to get rid of it.
Right.
So, and as you just said, normally you have the first lightning protection where the cable enters the building. So that kind of decides the question of where to put a lightning arrestor. It has to be before the patch panel.
Right.
Where it
The
comes
patch panel,
into.
the patch panel was on the quote wall of the building.
So if it's.
Well, that's what we had last year. So we had, it was a pavilion, and so right where the side of the pavilion where all the cables came, that's where we had the
Is
grounding
it
system.
open pavilion?
Yeah, it's all.
Okay,
all
so
four
you're
sides.
not penetrating a wall or.
Right. And then, you know, there was a cement slab, so we had to be where the ground rods were, so we were on the.
And unfortunately, I did not notice what grounding solution Tom implemented on the antenna cables, the feed lines that came in. I didn't look there.
Out of the antennas, out of the tower.
Well, but we're talking, you know, 3 potential points.
three rods.
Right, we're talking a rod at the antenna, a rod at the patch panel, and a rod for each.
He actually sets up a ring.
Is that what you meant, William?
He actually sets up a ring around each tower. There's a ring of grounded,
Right.
a couple of rods of a ring around each tower.
Is that 3 per tower? What were you saying, William?
No, I may have it confused with the ground system that we built for net control at MCM.
Okay.
You're going to have, as you said, a ground rod at the base of the tower or where that ring is. And the next grounding point that you'll have is at your patch panel. You don't want to have anything beyond that because you're using your patch panel ground rod as a single point ground, which all the antennas will come to, as well as all the arrestors on the patch panel.
Okay.
So
Well,
that's the standard
Right.
that we normally use.
Okay.
And following on what we did at MCM, at that point, we did 3 ground rods. 1 ground rod distance apart, just sort of a triangle. That was our entry point
Okay.
connection to ground.
Okay.
Lower L and C.
So we definitely need a follow-on discussion. Maybe we can get Tom to come in and do a presentation or something, please, to do a follow-on discussion about how we might address this issue with a grounding solution for the patch panel. What his thoughts are, whether he thinks we should be using a metal patch panel structure or we can go with something like this that may be more flexible.
Part of this project is going to be like a patch panel setup instructions and some plastic that goes with it, so and anybody can set it up.
Yes, yeah, that would be nice, almost a turnkey solution. That would be a great idea. If you could say, oh, I got a patch panel kit here that'll work for
Right.
all day.
Here are the instructions on how to set it up, so anybody can do it. Yeah.
Then we'll have to manufacture them and ship them out. Just a thought. Scott?
I assume that at some point we are going to test this out prior to next year.
Really like to understand and test, based on input from Tom, is how we should establish a grounding system in the field, given that we'll have a certain amount of equipment with us, and maybe set up a couple of antennas, run them into the patch, and then see what the practicality is of putting, lightning arrestors and ground rods at the patch panel, and seeing, maybe equipment we're thinking of using won't be adequate, and we might have to upscale. That's what I'm concerned about. Is that, everybody okay on board with that? Okay.
That would be the test for shop.
Any other questions or comments?
Yeah.
Yes, David.
I remember reading in the license manuals, proper way to ground is everything comes to one ground point, as opposed to having multiple grounding. Because you want to avoid grounding loops.
Well, you have 3 different grounds anyway. You have an RF ground, you have an earth ground, and you have electrical ground. So what are we talking about? We're talking about basically an earth ground for the lightning, right? Our electrical is taken care of because there are different schools of thought, ask Tom, he'll tell you, on grounding or not grounding the generator because of these lightning issues. So that's an electrical ground. Should we connect them together? We don't know. Some rig instructions specifically say don't do that, even though the case of the rig is actually got a ground screw and the bulkhead connector that comes out the back is on the case. So the instructions say, look, don't connect these together. Yeah, so I'm very, very confused when I read stuff like that, which is why I'd like somebody with industry experience to help me out. But I agree with you. There's a lot of myths and misinformation out there about ground rods and whatever. So I'd like to go with somebody who's actually experienced that. Because I've read a huge amount of information, a lot of it contradictory about grounding and towers, etc. Yes, Hank?
In the industry, there's been a lot of discussion over the years, and a lot of disparate recommendations. And at this point, the Motorola R56 standard is pretty much the accepted standard for grounding systems. And of course, there is always an exception to the rule, but it's based on good physics as to why those exceptions might occur. But if you follow the R56 standard philosophy, you will be in good hands.
Okay.
And that's based on the experience of the cellular industry in Florida, where they had 73 sites that every time somebody would say, oh, no, this is the way to do it, and they'd get a strike and they'd find out their equipment was not protected. So they had good experience at following that standard.
So did everybody hear that?
R56.
R56.
Motorola R56.
But it's a consequence of a number of industry leaders in antenna world and electrical world and so forth that brought that together. And that's primarily for the antenna coaxial cable, as well as the equipment that go in shelters and whatnot. We're in a unique situation being in an open type arrangement, but the same requirement for a single point ground is going to be there, and you don't want to put another ground rod over here. The ground rods that we were talking about at the antenna site, that's fine. It's when you get beyond penetration, you might say, into the building or into the work area, you only want to have that single point ground that has all those traces.
Right. It's like, you're crazy. You're going to bring an antenna into the building where the lightning can get to all of us? You're nuts. Yeah, I know exactly what you mean. So that's Motorola R56 standard.
How do you spell that? A-R-C?
I thought it was R. Romeo.
The
56.
letter R.
R, letter R.
Romeo 56.
Okay.
And I
So-
guess if anybody needs a copy, I may have an electronic version or PDF copy.
Okay.
To send it
Excellent.
out.
Thank you.
has done.
Dan, if you
Oh,
could.
thank you. You've already taken care of it, right?
Oh,
Just
all right.
Google it.
I was looking before I forgot.
Excellent. All right.
Well, that's definitive.
All right, so you can ask Hank or Fred for a copy if you need one. Put a request into Fred, and he'll provide a copy.
Just
That's
Google
great.
it. Fred said he
I
can't
just
lie
put in
down.
Motorola R56.
Google it, all
As a
right.
PDF.
So it's on Google, excellent then. All right, so I still think we need a follow-up discussion then for using that standard. That comes highly recommended, and using it in our field context with an open-air building. William?
Since everybody's going to go off and find a copy now, the admonition is simply make sure you have the most recent one, because it's evolved a long time. It's extremely valuable because it's gone through a lot of iterations. So make sure you have the most recent.
Which is what? Because there's one here that says 2005. I don't know, it was revised
That's
after
close
that.
enough. That's close, yeah. that's
Oh, okay.
close enough.
2005 or later.
Yeah.
Okay. Yes, sir.
Yeah, I have a comment with regard to the standards. I'm not trying to say anything about R56 or whatever. I work with industrial process control systems. A lot of industries have different standards and different requirements. So when you go out there and you say, oh my goodness, this contradicts, because I can show you documents where they say ground is shielded at both ends, grounded at this end, grounded at the other end, don't ground either end. I can find all of those.
And for what frequencies am I doing that for?
Well, the key thing is to understand why they set it up that way. There are important reasons why. So for example, Dave was saying you do a single point ground. That is a very common way of doing that in industrial process control. It's kind of gone by the wayside because as hardware has gotten better and better, there's less and less need for it. And it's an expensive way to do it. So just, my word is just be a little cautious about what your standard applies to. I think, certainly being an RF standard, that's probably most applicable to us. But if you go off and you Google something, you find, oh, here's an IEEE standard for such and such.
Well, you figure you've got 17 or 18 antennas out there, and the grounds are all crisscrossed and cross-connected, plus your feed lines are coming in from all over the place. How do you know anything's going to work right? We're slapping beaters on them and trying to see what the resonance of the antennas are, and then last June, we were getting situations where people on the CW, we could hear the bleed over on some of the other antennas despite the band filters. Then I was experiencing static whenever the wind would blow, we'd get a little wind gust, and my band would fade away and then come back. So it happened, in 40 minutes. So I don't know, we checked a couple of times, couldn't find any ground. So it might not have been grounding or a short issue, it just might have been the position of that wire when the wind blew in relation to all the other wires was giving you a null zone. So it's a mess.
Well, thanks so much for your time and interest. That's it for now. You can find out more about our Montgomery Amateur Radio Club by visiting our website at www.markclub.org.